This lesson is Unit 2, Section 2. We are now in Chapter 4. We're talking about polynomial functions. So just a refresher before we get into anything, the zeros of a function of any graph are going to be the x-intercepts. So in this case, x would equal 3 and x would equal -1. Or my factored form would have been x minus 3 and x plus 1, my intercept form, right? With whatever number was out front, and I noticed it was going the 1, 3, 5 route, so there was a 1 out front. So we're going to talk about polynomials, and a lot of this stuff you've seen before, so we're going to go through it a little quickly. So if you recall, a monomial is any number variable or a product of a number and a variable. A polynomial is a monomial or a sum of monomials. So a polynomial is just a bunch of terms being added together as long as each one is considered a monomial. So for each of these words, we're going to match up what the term is with its definition. So a monomial would then be a single term. A polynomial are multiple terms combined with addition or subtraction. Standard form is when all of the terms are arranged with their exponents in descending order. The degree is the highest exponent of a polynomial. The leading coefficient is the coefficient of the term with the highest exponent. So it's the first term when you are in standard form, the coefficient of that. And the constant is any term without a variable. And recall, when we're dealing with standard form, the constant always represents the y-intercept. So if we look at all of these, degree is based on the highest exponent. So if I look at my first problem, I don't have any variable at all, which means there's no degree, or 0. For this one, x to the first power, right, so a degree of 1. X squared is a degree of 2. X to the third, a degree of 3. X to the fourth, a degree of 4. We also have names for these like constant, linear, quadratic, cubic, and quartic. Type would be if there's just one term that was a monomial, or type, they could also be referring to constant. All right, we'll put those here. Linear, quadratic, cubic, and quartic, like quarter, quartic. So if there's just one term in the problem, it's a monomial. If there's two terms, it's called a binomial. 3 terms is a trinomial, and any more than 3 terms, they just go by the generic polynomial. And these are some things that a polynomial cannot have. So you're never allowed to have the, you can have fractions, but the fraction cannot have the variable in the bottom. You cannot have a negative exponent anywhere in your polynomial. You cannot have any decimal exponents in your polynomial, and it can't go on forever. So they can't use a ... to represent that it keeps going. So we're going to go ahead and classify these, right? Determine if it's a polynomial, and if it is, we'll be able to answer all those things. So when I look here, I don't have any negative exponents. I don't have any decimal exponents. Even though I have a fraction, the variable's on top. So everything here works for a polynomial. So I can go ahead and answer these questions. So the one with the highest power is over here, so I'm going to start with that. Negative x to the 5th over 8. The next highest term is 4, so plus 8x to the 4th. My next highest term is the squared, so plus x squared plus 3x minus 7. So the degree, the highest power, is 5. All right, we didn't give a name, a type for that. A leading coefficient, so the number attached to the x to the 5th is really negative 1 over 8. And our constant term, or the term without any variables, was negative 7. When I look at b, I have a power of 2, I have a power of negative 5, and I have a power of 3. So this is not a polynomial. Oops, spelled that wrong already. Polynomial. And that was because I had p to the negative 5. You cannot have any negative exponents. So there's nothing to answer there because it's not a polynomial. So you go ahead and try these, pause, and I'm going to show the answer. All right, so go ahead, check your answers. All right, so a leading coefficient is different than the leading term. So the leading term is the entire part with the number and the variable. So in this problem, the leading term, or the term with the highest power, would have been negative 10x to the third, and the leading coefficient is just negative 10. So when we ask for the coefficient, we're asking specifically for the number part, but the entire term was negative 10x to the third. All right, so just to know the difference between those two. So end behavior is going to actually be a very large part of what we do with graphing. So end behavior is really describing what happens where you have the arrows on the graph. What's happening when x is all the way to negative infinity and when x is all the way to positive infinity. All right, so it's how the ends of the graph are going to behave. So for even functions, they're going to go the same direction. So we have an example here of x squared and of x to the fourth. They're going in the same direction. Both arrows, if we had our arrows drawn, are pointing in the same direction. Whereas if I was looking at an odd function, on one end, it's going up, and on the other end, it's going down. And for all of my odd functions, it's going to be opposite ways. So the two things that are going to determine the end behavior are whether it's even or odd, right? Whether the power is even or the power is odd, and the leading coefficient, whether that's positive or negative. So end behavior for polynomials is always going to fall into one of these four categories. We're looking at the leading coefficient being positive or negative, and we're looking at the degree to be even or odd, right? Degree is never going to be positive or negative. It's always positive. So for even positive, it will look something like this, right? This is not exact. This is just an example. It's going to go both directions, both ways the same direction, and they're both going positive, right? The arrows are pointing up. So as the x value goes to positive infinity, so that means on the right side of the graph, the arrow's pointing up also to positive infinity. And as x is going to the left, or the negative infinity, the graph is also going up to positive infinity. All right, you don't have to memorize these because you could always get them from the picture, but you do need to memorize the pictures. So negative leading coefficient even is actually going to be upside down. Remember a reflection when we were doing our transformations? So as x is going to the positive infinity, the arrow is pointing down, so it's going to negative infinity. And on the left side of the graph, as x goes to negative infinity, it's also pointing down, so another negative infinity. All right, odd positive is going to look something like this, right? Almost like a straight line, like our linear functions. So on the right side of the graph, as x is going to positive, the arrow is going up to positive. And on the left, as it's going down to negative, it's going down to negative. And then for negative odd, it's going to be more like this. So as x goes positive infinity, the arrow is pointing down to negative infinity. And as x goes to negative infinity, the arrow is pointing up to positive infinity. So odd always goes opposite directions, and even always goes the same direction. So for even, positive is positive and negative is negative. For odd, positive stays with positive for positive. Positive goes to negative for negative. So we're going to describe the end behavior of each function, and we're going to, I usually draw a little picture for myself first, and then I can describe it. So I look for the highest power, which is 4. So that means I'm basing my information off this term, which is even, and the negative 0.5 is negative. So my picture is going to look something like this. So that means as x goes to positive infinity, f of x goes to negative infinity, right? It goes down. And as x goes to negative infinity, the graph f of x will also go to negative infinity. These should match. For b, again, highest term, so it's odd, because 5 is odd, and the negative 2 is negative. So it's going to be something like this. So as x goes to positive infinity, so on the right side, f of x goes to negative, and as x goes to negative, f of x goes to positive. So for c, that would be my term I'm looking at. So 2 is even, and that 4 is positive. So it's going to look something like that. So as x goes to positive infinity, f of x goes to positive infinity. As x goes to negative infinity, f of x still goes to positive infinity. And for d, I have 3.1x to the 7th, so the 7 is odd. The 3.1 is positive. So we're looking at a picture like this. So as x goes to positive infinity, f of x goes to positive infinity. As x goes to negative infinity, f of x goes to negative infinity. All right, so you're going to try the next ones, pause it, and I'll show the answer. All right, go ahead and check your answers. All right, so we're going to look at some graphs and we're going to talk about the different features. And a lot of these features are the same as when we were looking at quadratics or the parabolas. So domain is the input. So as long as it's not any holes in the graph, our domain is still going to remain all real numbers. So you could either write it as all real numbers, or if you wanted to write it in interval notation, that would be from negative infinity to positive infinity. The range, I am going to write in interval notation. So the range this time is not all real numbers. The lowest part anywhere on the graph is here, the negative 4.5. So the lowest, or the bottom, is negative 4.5. And then it goes all the way up to positive infinity. So that would be my range. The x-intercepts, I have 1, 2, 3, 4 of them. I have negative 5, 0. I have negative 3, 0. I have 4, 0. And I have 8, 0. The y-intercept I have there at 0, 5.2. Now, for increasing and decreasing, it's going to be a little different than before, because before we only had one area where it was increasing and one area where it was decreasing. So here we see that it starts out decreasing up until here when we reach -4. So for, we'll skip decreasing, hold on, increasing. Starts increasing here at -4 until it hits this top point again. So from -4 to 0.8, it was increasing. Then it went down again, and then right here it changed and started to go back up again. So it started increasing again at 6.3 and will go forever to positive infinity. So decreasing, we said we started with decreasing. So we start in the negative infinity and all the way to -4. And that's where it changed and went up again. And then it started going down again here at 0.8 all the way to the 6.3. So f of x is positive. So they want to know, where are the y values positive? What x values are the y values positive? So they're positive between here, right? This is all positive here, here, and here, right? Those are all my positive x values. Positive y values. So that means from negative infinity, oh, that's an 8, to the -5, we're positive. From -3 to 4, we're positive. And 8 for the rest of infinity, we're positive. If I want to talk about where is the graph negative, well, it's negative right here, and it's negative right here. So from -5 to -3, and from 4 to 8. All right, so we're using interval notation here. We're not just saying these are ordered pairs. We're saying it's from -5 to -3, and I'm not using the square brackets because at -5 it's 0. It's not positive. But as soon as I go past -5, it's negative now. Relative max and min. So when we talked about a quadratic, we either had a maximum value or a minimum value. But relative maximums and minimums are really the lowest or highest point between two zeros. So between these two zeros here, I had a relative minimum, a bottom, at -4, -1. And then it went up, there's a max there, and then here's another min at 6.3, -4.5. So then I had a maximum, a high point, at 0.8, 5.7. So we're really just describing the highest, lowest points we see. And then what is the degree and leading coefficient? So we're going to use our end behavior and work backwards. So I see that they're going in the same direction, and same direction means even. And they're pointing up, so that means it's positive. All right, let's do another one together. So the domain, all real numbers again, so that's -infinity to infinity. The range, arrows pointing in both directions. We don't have any top or bottom, so this is also going to be all real numbers, or -infinity to infinity. The x-intercepts, I have one here at 1, 0, and another one here at 6, 0. What are the y-intercepts? I had one here at 0, -4. Where is it increasing? Well, it's increasing here from -infinity till we hit 1. Then it changed direction, and now it starts increasing again at 4.1 until positive infinity. So it's decreasing from here to here, from 1 to 4.1. Where is it positive? So it's positive here, right? Nothing else on the graph is over the x-axis except for right here. So it's positive from 6 to infinity. Where is it negative? Well, it's negative from negative infinity until 1, and then again from 1 to 6. Now, I don't say negative infinity to 6 because at 1, it's not negative, it's 0. So I can't include that 1, which is why I had to start and stop. Relative max or min. Well, all I have is a minimum. Oh, no, I lied. There's a maximum there. So we'll start. Maximum was at 1, 0. And my minimum, or the lowest point I saw, was at 4.1, negative 12. And then degree and leading coefficient, well, it goes opposite direction, so it's odd. And it looks like it'd be a positive slope if I were to draw a line this way, so that's positive. So you're going to go ahead and try the last one, pause, and I'm going to show the answers. All right, so there you go. Those are your answers for the try. And that is day 1 of chapter 4, polynomials.